Yes. So the topic that I got was memory layout. So we'll start by discussing how the memory layout will be for a typical C program. That thing most of us will be knowing that. Even like Purani sister was telling, right? Like 1 second. Am I audible? Yeah. Cool, cool. Yeah. I forgot if I turned on the mic. That's it. Okay, so like she was telling, right, how static variables will be stored in BSS and all. So that is exactly how we'll be seeing it, and we'll also see how it will be slightly different for a microcontroller also. Okay, so like why we need to know the memory layout. So the different sections in the program is going to get stored in different regions of memory. That's why we need to understand that. In a typical C program, we'll generally see like the text section, initialized data, uninitialized data, which is the BSS, then heap stack, and this region is also there, but generally people forget it, which is like command line arguments and environment variables. That is like the last minute variables and last minute values that we pass through the like C program during the execution itself. All these variables, like this regions and all, they will be allocated during compile time itself. This happens during runtime. And initialized data and all, they can change during the program run. Heap stack also can change during the program, but the text section pretty much remains constant in most of the cases. So the text section is actually going to contain the like compiled version of the program that we are running. So it generally doesn't change. And the initialized data, dot data section is going to have the initialized data, the data that we have already given value to. Uninitialized data, like if we have set it as zero, like or if we didn't like initialize it to any value and we have just defined the variable only, global variables and static variables will be stored in both of these places. Even like local static variables, they will be stored here only, and depending upon the function we'll be able to access them. For that they kind of use something like checking variable kind of, like am I present in this function to access it. But that is kind of really like interesting to note, because like even though it is a local static, it will be present in initialized data or BSS only. Then heap is going to contain like the variables like we are going to create during runtime that we are dynamically allocating, and stack is going to have the variables that are like locally generated, and the values that are going to be there due to a particular function call. It can also have values like when we are switching between different functions, similar to context switch, so that no, like it stays there as long as that particular function is going to run. We create something called as a function frame that will contain all the variables that can be used in the function. As soon as the function is over, that function frame gets destroyed. Heap is going to contain, like as I told, like we can create variables of like we would have seen like creating arrays of dynamic size. That and all is possible by using heap and using a pointer for accessing it. And one thing is that like heap is going to not have contiguous memory allocation, so it's going to be connected via linked list. So stack and heap doesn't have like a fixed size. Like if the stack is too long, the heap will be small. If the heap is too long, the stack will be small. They kind of grow into each other. So if the stack kind of overflows with the heaps region, we have what is called as a stack overflow. So yeah, I told this executable version of the code and data segment, global and static variables. This is actually block started by symbol, but in some places they say block standard by symbol also. But the actual thing is block started by symbol that are uninitialized are stored here. And heap segment, like these are the functions that we generally use for creating heaps. And local variables, each function has its own frame. Tools, all this. And like typically for a microcontroller and all, either this thing will actually happen within our system itself. We don't really have to do much of any work for it if we are running it in our computer, if we are running the program in a computer. But if we are doing it in a microcontroller and we are writing bare metal code, means we have to write it from scratch. I mean, like when we are using PIC microcontroller, it's fine. Like that compiler itself is running it for us. But typically when we are like running a actual thingy for like if you want to write programs in chip level, we have to write the linker script. I will show that also how I generally go about doing that. So yeah, each stack frame we have to define these also. Like it will have a static pointer, like file, like frame pointer, stack pointer, and the frame pointer, and program counter also. So I was talking about the stack frame. No, this is the general structure of the stack frame. Like for each time the like a particular function is called, one frame will be created with all these particular variables. But we will not really know that because we can't really see it. It's for like we have this one particular stack. In a stack, we are going to call a function. If we have other function calls from that function, that will be stored first. Then the saved registers, like saved registers might not be used for general C program, but if I am going from, like for a microcontroller, I am going from one mode to another mode, like switching between modes. At that time, we have to save the registers. Like you guys will be aware of this thing, no? Like from moving to ARM state to thumb state and all. So at that we have to save the important registers like the link register, program counter and all. So that when we come back after finishing that particular function, in like when the stack frame is going to get popped, this value will be taken again. Local variables for that like function that we already discussed. Save frame pointer, link register, past arguments. Past arguments we have a separate memory space for that. It's different from local variables. Like arguments which are passed as input to that particular function, and of course that's the function point. So like typically we mention all the regions where what should start and all in the startup file actually. Like a typical startup file will have things like this. Like we have to initialize each of the variables and where we should look for what. Exact addressing will be done in the linker script, but the memory map will be actually done in the startup file only. Yeah, it is not important. Okay, like what we were seeing till now was like how it will be for a general C program. That can be extended for RAM also, how generally things will be stored in RAM. Now, if we look in the case of microcontrollers, things will be slightly different. For microcontrollers, we cannot store, BSS and all in flash. So in the flash memory, we don't really have BSS segment. So how some microcontrollers will do means like you can either program it fully through RAM or you can program it like through RAM and ROM. If you're programming it through the flash means like you don't really have to worry about it. If I give an example means like if you have used like Arduino or ESP32, if you program that microcontroller once means even after some time you'll be able to use the same program, no, even after plugging it after a long time you plug in again, the old program you saved so many days ago will be still there. That is because it's getting programmed through flash. This thing is different from the traditional, what we do in the computer and all. So in this we don't have the BSS initialized data we have. Then RO data, read only data, this data cannot be modified. So then we have a dot text section also. RO data will have like, yeah, hello. Mhm. No, I mean, you can save it like that. But typically in microcontrollers, how we have it means the code section will get stored in that flash memory. Is it clear? Yeah, you can do that also actually. Like, yeah, it's totally about convenience. If you know the memory region, you define it in linker script, you're good to go. You can store it wherever you want. Yeah. So I have just roughly written what is going to stored where because initially when I saw it was kind of confusing for me. So dot text section, the code section, generally we store it in flash only in microcontrollers because it will be very annoying because like each time you turn off the power and the code goes away, you have to program it from scratch means it's hard. So generally we use it in flash. Dot data section, that is like initialized data is sometimes stored in flash also in RAM also, but typically we follow RAM. DSS, it's always stored in RAM because it's uninitialized data. It is going to have zero value. We cannot load it from flash and expect it to remain zero for the entire program run, right? So read-only data is from flash because we should not have the access to change it. Stack and heap should be in RAM only because they're going to continue growing, shrinking, and all. So yeah, as I was telling for the linker script, I'll show it. One second. It should be somewhere over here. Uh, this is actually one thing I wrote for something else, but I thought it can be useful here also. So, we first mention where each memory address is going to come. Then this is just aligning only. Like any section that has this is the text section. I want the text section to have any section that starts like text. And to PSRAM means it's like pseudo SRAM. This is one thing that I used in internship. So I have written it according to that. This is the data I used for that. So yeah. So memory program. No, this is the linker script. I'm writing the program, and we don't have a particular flasher for it because it's very what to say we are the microcontroller is built externally. It's a custom microcontroller, so we don't have a proper flasher like Arduino or ESP or even for PIC. Like for PIC also we have PyKit 3. No, we didn't have anything like that. So for flashing it, we need something like proper memory allocation that is done by this linker script by ourselves. Yeah, I mean, one thing you have to make sure is that where your flash RAM and SRAM size is going to get started from. Only then you can use it for any program. If your PSRAM is not starting at this address and you define it like that, means you'll get access fault error. Yeah, because you store access fault. You cannot store in that particular address like that. You'll get error. If you had some other internal program in that place, and so you have to change the addresses and all accordingly. And this is for read-only data. Like I have added this so that it doesn't get overwritten, linked again and again. Static data and static cases and stack frame. The starting and end of this all this I told no, it will be defined in the start.test function, start.test file. So it will be initializing the variables, and we'll also be initial telling where what should start. Yeah. So this one was actually looking really complex, but in actuality we don't really have to write that complex stuff for typical programs. Like this was a simple serial communication that I used did in RISC-V systems. For that, the linker script was super simple. So this thing is like this because I did it in the system itself. So I just had the text and data segment. I didn't even use the stack and heap segment. Same thing. If any segment is going to have the label data, put it in the data segment. That is entirely what it means. Yeah, and just a final thing that I would like to show, this is Geek for Geeks only. So they have clearly shown how things work. Here they have just initialized a global variable. They have not added value, so it has to go to BSS. Initially the BSS was 8. Because of this, the BSS becomes 12. Here they have added a value. Here also they have initialized it, a static variable, but they didn't they have not initialized it. I'm sorry. So it still goes to BSS. Since they have initialized it, it will go to data, and this one will go to BSS. And this one and this one both are initialized, so both of them will go to data. Yeah. So you might have this doubt, no? How will I'll be able to see the memory mapping? If you are in a Linux system, you can always check it. In Windows, you can't check it. One second, I'll go to that particular folder. Mm, so, mm, okay, now I give files, um, L- did I not build it? One second. This is I'm operating in Linux right now. Yeah. Okay, firmware.dump is only that. I have to build it. One second. I'm sorry. Mm, Which one you're asking? Linker script you're asking? The linker script actually you can write it in Windows or Linux. It's not a matter. If like for building this entire thing, if I'm in Linux means it is easier. If you're in Windows also you can use like WSL or one more thing is there. What was that? Wait. Okay, I have one more. I have made some changes yesterday, so it's not working. Wait, I have one more thing that I can show for now. If I debug the changes and all, it will take time. Uh, Download. Do I have that firmware dot? Please be there. Finally it's there. Okay, this is the previous version. I had saved it over here. Okay, well, I'll just show this one now. Yesterday I was making some changes, so it had gone like. Mm, Find firmware dot. Yes. So, like, Linux, this is proof that Linux or any operating system, இதுல வந்து we can see it clearly. In Windows and all, it's difficult to see this particular orientation. We can see how typically a file itself is going to get stored like this only. The separate text section, data, and BSS for any program. Yeah. Yes, that's it from my side. If you have any doubts, you can ask.